Hello again. I think this is going to be what now? Video 20. Let's now go back. You can see that I've pulled back the code that we were working on with the motors a little bit ago. The one where we had the pulse width in, but we did not have any mapping function. And to show you how easy to put this map in, it's incredible. And this won't take long, but we'll play with it for a little bit. Let's go down to our section of code. Recall ever so briefly here, what we do is we gather the two values, value 1, I should label that value 1 and value 2, but value and value 2, which are coming in measuring the amount of light which is striking these two photoresistors, which changes the resistance, which changes the number of electrons, which flow into the input pins. Okay, and so we have that number here, and then we call these two routines, the left clockwise and the right clockwise PWMs. And if we jump up to the left clockwise PWM, you can see that we of course set the pins in the right direction, so the motor rotates clockwise, and then we do an analog right, and then we stimulate the pin, which is the one that hooked up in my case, I think it was pin 4, that then flashes on and off very rapidly the enable pin at a rate which is dependent on value. Okay, but remember the photoresistors were taking in values from about 30 all the way up to about 1,000. Okay, so we can only handle a number up to 255 here, so we need to scale it. And here comes the map. Okay, let's do it quick and easy to start with. It is remarkably easy. Actually, I'm going to show you something else kind of cool. Because we're going to play with this, we're going to come back to it, we're going to test it, we're going to build on it. I'm actually going to toss in a little variable right here. I can do that basically anywhere I want. So we have the left, let's go left underscore, let's call it speed. That looks good. Is equal to the map of, well, we want to map the left one, which is value. Okay, we want to map value, which we said goes from 0 to 1023, and we want to output it to a value of 0 to 255. Wow, that's easy. And then that means that no, we don't want to pulse our motor at value. We want to pulse our motor at left speed. How simple is that? Okay. We're going to come back and comment that in a minute, because what we're going to do is I'm going to copy this and I'm going to go down to our right. Here it is. Okay. And let's make this logically right speed. And it's actually getting it from value 2. So we put a 2 there. And so the variable right speed is going to be the mapped value of value 2. And it's going to scale it between 0 and 255. So now we need to take this and put it here instead. That's it. This should work. Let's see what happens. We'll turn it on. And what do we got to do? We got to give these guys a kickstart. Come on. Wow, look at that. Okay. So right now they're in a state where if it gets darker and darker and darker, it gets faster and faster and faster. One at a time. Okay, well that works well. Now one of the things that bothers me is, again, in the robot world here, well, two things bother me. One is our motors didn't start right up. We can play with that. There's several ways we can kick that in. The other thing that bothers me is I don't think I ever want my motor to go that slowly. I mean, it's not going to have any real torque or power. If it was hooked up to wheels, it would probably just stall out. Especially driving it at only 4.8 or 5 volts. So why don't we start off by saying, hey, let's just not make it go any slower than 100. Should we do, let's go like 80. Let's go no slower than 80. I'm going to come up here and change that one. Alright. And I'm going to... Okay. So now, you can see our minimum speed is 80 and our maximum speed is 255. Alright? Now, let's say you're saying to yourself, geez, you know, I'm not sure if I really want my robot to go slower as it approaches the light. You want it to maybe speed up. Okay? So right now, it doesn't get fast until it gets... This would be a great design for a robot. I guess you could invert the code and do all kinds of stuff. But right now, this robot's going to be running as fast as it can into the dark. Okay? It's looking for dark. It's going to go faster and faster. It gets darker and darker. There's nothing stopping me from simply flipping these two around. Okay? So I can say, well, let's go from 255 to 80. So let's try that. Okay. So watch, right now, the motors are fastest in the dark, slowest in the light. Okay? This should flip it around. Oh, we're going to really have to give these guys a kick. You know what? Let's do this, because right now I'm running these things off just USB, which does not have a lot of power. Eventually, of course, you're going to be running on batteries, which will give it a lot more kick. Let's make it so the motor gets a kick right at the beginning. If you want a piece of code, I don't know if I've actually explained this before. The setup is just like the loop, except the setup runs only once. Okay? The loop runs over and over and over again, although we can force it to run only once. So what I can do, actually let me stop the little annoying buzz here. Hold on, we'll do my motors off thing. Okay? Let's give the motors a little kick. And we're going to do it in setup. So that way they start off running. We'll get over that inertial resistance. I'm going to take and copy all that on the left. And I'm going to bring it up here. We'll put it before the serial begins. And so this sets the direction. We don't want to map anything. Okay. And actually, we don't want to do an analog write. We just want to do a digital write. Of the pulse width pin, and all we really want to do is set it high. Does that make sense? Originally, when we first started playing with the motor, we just had those pins, the enable pins, hooked straight into the bus. Okay, and they were always high. So what we've done right here is we've taken that enable pin and we have individually digital write selected that pin and made it high. And if we put in a delay, oops, I'm going to do this. There we go. Oh, I don't know. We'll let it run for a second. Okay. It's going to hold these three pins in their position for 1 full second. Okay. So it's going to have 1 second of full power to kick it in and get it moving. before it actually then jumps down to the rest of this stuff and eventually gets into the loop. Let's do the same thing for the right. Okay, so I'm going to copy this. Again, this is probably not even going to be an issue when you're on batteries because you're going to have more current available to you. Give it a little kick when it gets going. Alright. Boy, I definitely have to comment because all these comments are totally wrong now. Okay. So what we want to do is we want to get rid of the map function altogether. We want to change this analog into a digital, and we want to make it high. Okay, so that should kick our motors on for 1 full second. So hopefully that'll give them started, and then once it's got them running, it will then go into the mapping function. Once again, I can't stress enough, I don't think we're going to have a problem with this once we actually get them onto batteries. So let's go here. Yep, kicks them on. And what were we doing? We were looking for... See? Switches speeds, slows down in the dark, faster in the light. So if your robot was looking for a light over here, this wheel would spin faster, turning the robot toward it. If there was a light over here, it would spin this wheel faster and turn it toward it, until eventually they start bouncing back and forth and the robot goes straight toward the light. Even if their speeds of the motors are a little different, it'll automatically adjust because it's going to be looking for the brightest lights. What else do we need to do here? Of course we have to comment it. I'm already at 12 minutes. I'm going to make sure, please, 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 you comment it, because this is even, now that I copied and pasted stuff, my goodness, we are, we're just sending the wrong message altogether. We're going to have to say, we're going to hold the enable pin high. Alright, that one we can copy to this one as well. And we want to give this little comment here. We're going to give the motors 1 second to warm up. And what else did we change down here? We haven't commented this. I'm going to make this the output X is equal to the so what do I want to say? I guess I'm going to just define what's in there. So we have the map of the input variable this is lowest value, highest value. I should put that as highest value in, lowest value in, and then we have lowest and highest value out. Out. Okay? So do make sure you comment your code, because we are going to be growing some code into dizzyingly long lengths. Alright? And as you can tell, I like to copy and paste. And it's certainly a lot easier to deal with it if you understand what it is you did. Okay? So let's wrap that up. I think the next video we're going to actually start building a chassis, because I'm getting tired of my motors bouncing around the desk. I'll see you soon.